Oumuamua, an enigmatic interstellar object that captivated attention in late 2017, is set to collide directly with Earth in just 2 weeks. This cosmic event is particularly terrifying because Oumuamua shows no signs of decelerating. Scientists are concerned about the possibility of space probes sent from distant civilizations, similar to those sent by humans, such as Voyager and New Horizons. Avi Loeb, an expert in plasma physics, has suggested that Oumuamua might have been an alien spacecraft. However, there are challenges in achieving this goal, such as the immense distances in space and the time required to ensure the probe arrives before their civilization collapses. Despite these challenges, the arrival of Oumuamua in 2017 sparked excitement among scientists who had been waiting for an interstellar visitor like it. In 2017, Thomas Zurbuchen, NASA's Science Associate Administrator at the time, announced the confirmation of interstellar objects like Oumuamua, sparking immense interest among astronomers worldwide. Just 2 years later, another interstellar object, 2I/Borisov, was spotted. Unlike Oumuamua, Borisov had the typical features of a comet with a distinct tail and coma. By studying Oumuamua's brightness as it moved through space, astronomers deduced its dimensions and shape. Oumuamua's journey is traced back to a possible close encounter with 4 stars, with a red dwarf star, HIP 3757, being its closest pass. This revelation left astronomers wondering about Oumuamua's origin. Did it originate from there? Or has it been drifting through space for millions of years? The solar system is like a bustling neighborhood, with planets, asteroids, and comets orbiting around the sun in tight loops. In 2017, Oumuamua entered our cosmic neighborhood, moving at a blazing speed, barely affected by its gravity. It was first noticed on October 19, 2017, by astronomer Rob Warwick from the University of Hawaii. However, catching a glimpse of Oumuamua was not easy due to its tiny size and rapid movement. The Hubble Space Telescope and other powerful observers captured stunning images, revealing Oumuamua as a mere speck against the vastness of space. As Oumuamua speeds away, heading towards the constellation Pegasus, it fades from our view, disappearing into the depths of the Kuiper Belt, a region beyond Neptune filled with icy objects. Some speculate that Oumuamua might be an alien probe, while others think it's just a dead comet, stripped of its gases over billions of years. Oumuamua's fleeting visit has left astronomers and space enthusiasts captivated, sparking debates and fueling our curiosity about the mysteries of the cosmos. Oumuamua, a mysterious interstellar visitor, has been the subject of various theories and observations. Some suggest it is a fragment of nitrogen ice, while others propose that cosmic rays interacting with surface ice in interstellar space freed hydrogen gas trapped in water molecules, creating a supply of hydrogen gas trapped in amorphous water ice. Astronomers Avi Loeb and Shmuel Bialy from Harvard University have suggested that Oumuamua could be a solar-powered spacecraft, explaining the peculiarities observed in this interstellar visitor. The true size and shape of Oumuamua remain unknown due to the lack of a detailed photograph. Astronomers rely on its brightness and knowledge of how asteroids and comets reflect light to estimate its size. Some scientists doubt the comet theory as no coma or tail has been observed around Oumuamua. Another theory involving sunlight suggests that Oumuamua's observed movement could be due to solar radiation pressure. They speculate that Oumuamua could be a light sail, a technology demonstrated in space missions like the Japanese Icaros probe and NASA's NanoSail D2. These light sails use photons' kinetic energy to propel themselves through space. Conventional rockets won't catch up to Oumuamua as it heads towards the outer solar system. However, sending small robotic probes with sails hurtling towards it at high speeds could be feasible in the future, with projects like Breakthrough Starshot aiming for this. Studying Oumuamua's visit can prepare us for future encounters and better examine other intriguing objects currently in view. If the Oumuamua space probe returns, it would prompt further considerations and preparations. Building a Karelian shipyard and considering the steps we should take if the asteroid space probe returns are essential for constructing spacecraft capable of pursuing it. One suggestion is to send a craft after the asteroid probe, but the challenge is immense. Oumuamua is traveling at a hyperbolic excess velocity of $5 per year, surpassing anything humanity has launched into space before. The concept of wormholes poses significant challenges, including collapse, links to other universes, and the lack of construction knowledge. In 1935, Albert Einstein and Nathan Rosen introduced the concept of wormholes within the framework of general relativity. They proposed the existence of Einstein-Rosen bridges or wormholes, theoretical passages connecting different points in spacetime. These wormholes could potentially create shortcuts, reducing travel distance and time across the universe. Although Einstein's equations suggested the possibility of wormholes, none have been observed or confirmed to date. Some equations even hint at the presence of wormholes associated with black holes, but verifying this is challenging. At the heart of this concept lies Einstein's theory of spacetime, which he envisioned as a fabric encompassing the entire universe. According to Einstein, the interaction of mass and energy warps this fabric, creating valleys that influence the motion of celestial bodies like planets and stars. This manipulation of spacetime forms the basis for gravitational effects rather than a direct force of gravity. Einstein and other scientists have proposed the existence of various types of wormholes categorized based on their properties: transverse wormholes, non-traversable wormholes, one-way wormholes, white hole wormholes, two-way wormholes, intra-universe wormholes, and inter-universe wormholes. The exploration of wormholes remains a captivating subject, blending theoretical physics with imaginative possibilities. The burning question is where these wormholes in our universe are. While theoretically they could exist within black holes, white holes, and other massive celestial bodies, they remain largely theoretical. This uncertainty is not uncommon in the world of science, and just because something is theoretically possible doesn't mean it's guaranteed to exist. Einstein's theory of general relativity provides a solid mathematical foundation for the existence of wormholes, but theories are still subject to interpretation and further investigation. While we may dream and speculate about wormholes, their elusive nature reminds us that there's still much to uncover and understand about the vast cosmos. Understanding the mysteries of wormholes is crucial in the quest for knowledge. The most plausible explanation is rooted in the Big Bang theory, which suggests that the universe began with a colossal explosion, scattering matter in all directions. Over millions and billions of years, this matter merged to form the universe we know today. Some speculate that these holes are interconnected by cosmic strings, forming a network of wormholes waiting to be uncovered. Unlocking the secrets of wormholes is essential to understanding the mysterious nature of our universe. For example, in Star Trek, wormholes were only visible when someone approached them, and finding a stable wormhole was rare. If true, it could mean that all galaxies are connected by the cosmic strings mentioned earlier. Wormholes, or openings in space that connect different areas, are often considered to exist without interference due to the natural pull of gravity. However, if wormholes were created during the Big Bang, they may have closed up over time due to the forces at play in the universe. The cosmic strings could be a reason why some wormholes persist, providing the energy or matter needed to keep them open. A stable wormhole is a dream that ignites excitement and curiosity among science fiction enthusiasts and scientists alike. To understand and harness the power of wormholes, there are several intriguing ideas, such as creating a launch pad on the outskirts of the asteroid belt, the warp bubble, or constructing a warp engine. However, constructing a warp engine faces numerous hurdles, including the need for negative mass, which remains a mystery in the cosmos. The Hubble Space Telescope captured images of 2I/Borisov, a comet that hails beyond our solar system. Scientists are fascinated by its origin and what it can teach us about the wider universe. The comet's features resemble those of the materials that formed our solar system, making it a remarkable object. Its swift movement, traveling at an astonishing 110,000 miles per hour, makes it an attractive target for space exploration. Scientists predict that Borisov will pass Jupiter and then vanish into the depths of space, never to return. This sets a ticking clock for NASA and other space agencies as they race to unravel more about its composition and behavior before it bids farewell. Hubble stands ready to monitor whatever unfolds next with its advanced sensitivity and resolution. Although scientists are eager to gather more information about 2I/Borisov in the coming months or years, we already have some clues about its nature. We have identified it as a comet, a significant detail that helps characterize this interstellar traveler. One key indicator of its cometary nature is its coma, the hazy cloud surrounding the comet as it travels through space. Determining the comet's size has been more challenging, but current estimates suggest the nucleus ranges from about 1.4 to 6.6 kilometers in diameter. In essence, 2I/Borisov behaves like a typical comet found in the universe, except it's hurtling through star systems and happened to pass close to our own. Oumuamua, a comet with unique characteristics, was discovered by a team of humans in 1977. The Voyagers and New Horizons probes were sent out to explore the vastness of space beyond our solar system. The Voyagers first zoomed toward Jupiter, using its gravity to catapult them onward to Saturn. They captured images of its majestic rings and the mysterious Titan. After Saturn, Voyager 2 headed for Uranus and Neptune, becoming the only spacecraft to visit these ice giants. Voyager 2 also holds the record for capturing the first images of Earth from outside our solar system, the famous pale blue dot photo, taken from a distance of 3.7 billion miles. Both Voyager probes carried messages for any extraterrestrial civilizations they might encounter. These messages were encoded on golden records, containing sounds, images, and greetings from Earth in multiple languages. The records were intended as time capsules, telling the story of our world and humanity. Even after decades of travel, these probes remain connected to Earth, sending back data until their power sources can no longer function. In recent years, the discovery of exoplanets, planets beyond our solar system, has reignited the quest to find life elsewhere in the universe. The sheer diversity of planets has surprised scientists, with many discovered in the habitable zones of their stars, where conditions might allow liquid water. The most intriguing exoplanets lie within these habitable zones, leading to debates about whether life could exist there. Proxima Centauri b, one of the most well-known exoplanets, orbits the closest star to our solar system, Proxima Centauri. This exoplanet is slightly larger than Earth and lies within the habitable zone, making it a prime candidate for the search for extraterrestrial life. Scientists have detected exoplanets in the habitable zones of other stars, such as Kepler 452b and TRAPPIST-1e. The James Webb Space Telescope, with its advanced instruments, promises to revolutionize our understanding of these distant worlds. Scientists are particularly interested in studying the atmospheres of exoplanets, searching for signs of oxygen, methane, or other biomarkers that might indicate life. However, it's essential to remember that our current technology is limited, and we can only gather indirect evidence from these distant worlds. The excitement surrounding exoplanet discoveries fuels our imagination about what other forms of life might exist elsewhere in the universe. While we may not have concrete evidence yet, the search continues, driven by the profound question of whether we are alone in the cosmos.